This is the tutorial for the Motions of the Sky lab. This lab gives you a chance to work with a Planetarium app, a program that lets you see what the sky would look like from any place and any time. We'll be using the app to see how the sky moves from different locations on Earth. We'll speed up time to watch the effects of the Earth's spin and orbit on the celestial sphere. Planetarium apps are programs designed to show you the sky from any location on Earth at any time in the past or future. Many of them give you views from different locations in space as well. There are several of these applications available for phones, tablets, or computers. The instructions in the lab are written for the Stellarium and Sky Safari apps, but others do the same thing. You'll just need to review the instructions with other applications to make sure they're showing you the same things. Note that there is one feature that many phone and tablet-based apps have that is very helpful for watching the sky. You can set them so that they show you what is in the sky in whatever direction you're pointing your device. You won't need that for this lab, but it does help you if you're out observing the night sky. When you open a Planetarium app, you see a view showing a portion of the sky. There are a few adjustments we can make to get the most useful view for this lab. The first step is to get the right field of view. The field of view is just a measure of how much of the sky you can see at once. We want to start with a full 180-degree field of view. This means you're looking at the entire sky at once. The sky looks like a circle with the horizon all around the edges. On touchscreen devices, you can usually use your fingers to squeeze the view down to this. You also want to remove some of the things that may distract you. Open up the Settings menu and make sure that the horizon is opaque and flat. Turn off the daylight so we can see stars even during the day. And turn off labels for things we don't need, like the planets and constellations. You can also control time in these apps. There are controls that let you set any specific date and time. You can also make time flow at different speeds. Even watch years or centuries go by in seconds using the time flow controls. You should play with these controls until you're comfortable using them. If you want to get back to the current time, you can also reset to now. Now let's see what these apps can show us. We'll start by observing from Quito, Ecuador, a city very close to the Earth's equator. Find the location controls in the app you're using. In Stellarium, you'll want to shut off the Use GPS option. Find Ecuador in the list of countries, then select Quito using the list of cities. Once you've set the location, use the time forward controls to watch the sky move through a night. Make sure the time steps are short enough that you can watch the sky move without it jumping around. Notice that as the sky moves, there are points that don't appear to be moving near the northern and southern horizons. These points are the northern and southern celestial poles. Look for the bright star closest to the north celestial pole. Click on this star and determine its name. You may need to leave the time flow mode and zoom in on that part of the sky. List the direction the stars appear to move around this point. Then look towards the south celestial pole and see what direction the stars move there. Remember to keep time moving forwards as you determine which direction the stars move. Now we're going to change location to the Earth's North Pole. Set the location in Settings by resetting the latitude to 90 degrees north, or as close to that as the software will let you get. From this location, the North Celestial Pole is straight overhead instead of being on the horizon. Use the time controls to watch how the sky moves from this location. Remember that the celestial pole is the point that the sky appears to spin around. Notice what is similar and what is different from what we saw at the equator. Which direction does the sky seem to rotate now? When you look at the horizon, how do the stars appear to move? Once you've finished answering the questions from the North Pole, try resetting the location to the South Pole and repeating your observations. Discuss whether you see another bright star close to the South Celestial Pole similar to the one close to the North Celestial Pole. Again, you may have to zoom in to the point the sky is rotating around to see if there is a bright star there. Now use the location controls one more time to set the location to wherever you live. You can look for your town on the list of cities, or you can use the GPS or current location options to go there directly. Again, watch how the stars move in the sky. Notice that some stars rise and set, while others stay up all the time. Have a look around the North Celestial Pole and see if you can identify a couple of stars that stay up all the time. Ones that don't drop below the horizon at all. Remember that the North Celestial Pole is the point the sky appears to rotate around, not the northern horizon. Also remember that you can find the names of stars by tapping on them. Once you've done that, look towards the southern horizon and then make the horizon transparent using the app controls. You can still faintly see the horizon along with the marker for due south. Then see if you can find a star that never gets above the horizon as the stars move. The last piece of the skill building part of this lab is a look at annual motion. In other words, seeing how things in the sky shift over days, weeks, and months rather than just one night. This motion is based on the Earth's orbit around the Sun rather than its spin. Starting from where we were, you want to continue observing from your hometown. You should make the horizon opaque again, and you want to focus on either the eastern or western part of the horizon to start with. Make sure you keep the daylight off so that you can continue to see the stars in the day. Use the time controls to step forward by 1 or 2 days at a time. Depending on the version of Stellarium, you might have to use the date and time settings to do this rather than just stepping forward with the time flow controls. From day to day, which direction do the stars appear to move against the horizon? Is it eastward or westward? You may have to take several steps to get a clear measurement of this. Once you've found this part, try finding the sun in the sky. If the sun isn't currently above the horizon, you'll either have to adjust the time to daytime or make the horizon transparent again. Again, step forward by a day or two and see which direction the sun is moving against the background stars. Is it eastward or westward? Make sure you're comparing against the stars, not any planets that might be in that part of the sky. If you're not sure, turn the names of the planets back on. Now that you've finished the skill building part of the lab, it's time to move on to the exploration experiment. Don't be fooled by the fact that you're not seeing detailed instructions here. In the exploration experiment, you have to develop the procedure yourself, just like the professionals do. This part is as much or more work as the part we've done, so give it the time it needs. The goal here is for you to apply the techniques you've developed in this lab to a question that you can explore yourself. You're welcome to come up with your own exploration experiment, but if you do, you should probably check it with your instructor to make sure it's doable with the tools you've got. If you don't have your own suggestion, we've listed several possibilities here. One is for you to determine which constellations the sun passes through each year and which date it goes through them. Another one asks you to figure out how the amount of daylight and night change through the year. But the third option asks you to figure out how the phases of the moon work using the Planetarium app. In other words, you'll need to observe what the moon's phase is and where it is in the sky relative to the sun throughout its cycle of phases, and see if you can develop an explanation from that. The last one we developed has you plotting where the sun is in the sky at noon throughout the year and discussing why this changes. Whether you pick one of the options we suggested or come up with your own, you'll need to do a write-up that includes your question and a hypothesis that states what you expect and why. Then you'll need to describe all the steps you take. This should be the sort of detailed step-by-step description that would allow someone else to duplicate your work. Your write-up should also include all of the data you take, and if appropriate, put in some screenshots of what you saw. A picture is often worth 1,000 words in a lab write-up. Finally, include your conclusions, where you discuss whether your data supported your hypothesis or not, and what went right and wrong in your experiment.